Good afternoon, good evening, and good morning from wherever you're joining us from today. My name's Sarah and I'm the Program and Event Manager at the Reactor in Sydney, Australia. Welcome to another Microsoft Reactor Sydney live stream event. Today I would like to welcome back Deepak and Nirmal. So just a bit of background on both. So Deepak is a Microsoft Azure MVP, currently working as an Azure Capability Lead with Insight Enterprises Perth. And Nirmal works for Microsoft as an Advanced Networking Global Blackbelt, looking after customers across Asia, Australia, and New Zealand. Before this role, he worked as a cloud solution architect, helping customers migrate their on-premises workloads to Azure, and worked on large-scale remote work initiatives, enabling organizations to operate during the pandemic. So a bit of housekeeping today. You'll see in the comment section, I've already entered the check-in link with the event code 14669. So please check in for today, where you'll find additional resources kindly provided by both Deepak and Nirmal from today. We will be speaking for about an hour with 10 minutes for questions included in that. However, do send us your questions throughout, so we'll try and answer as many as possible towards the end. And at the conclusion, we'll also share with you a link to the feedback survey with the same event code 14669. So if you have time to take that survey, that would be much appreciated. And if there's anything that you missed from today or would like to reference back, this recording will be available on our YouTube channel straight after today. I'll also share with you the link to that a little bit later in the session. But for now, I'll hand the floor over to Deepak and Nirmal to begin. So thank you very much to both of you, and over to you.
Cool. Thanks, Sarah. Good morning, good afternoon, good evening, everyone, based on the region and location you have joined in. So my name is Deepak Maheshwari. I'm Azure MVP, and I'm joined with Nirmal, who's the Global Blackbelt Azure Networking. And today we're going to talk about Azure FrontDoor, and we'll be talking about the new SKU, which is the FrontDoor Standard and Premium, which is in currently preview. So without any further ado, I will kickstart with the agenda. So we will talk about different load balancing solutions when it comes to Azure. So FrontDoor happens to be one of the load balancing solution, but we'll talk about what are the other load balancing solutions and which one you should use in what scenario. Then we're going to talk about the FrontDoor and its architecture and dynamic app acceleration. Then, I'm going to talk about the securing applications against the attacks using the web application firewall, and what are the steps we need to take in order to migrate any on-premises website to Azure, FrontDoor. Nirmal will talk about analytics and dashboard, and will give us a demo about what are the new enhancement in terms of analytics and how the dashboard looks like. So throughout the presentation, if you have any questions, feel free to post it into the chat, and we would try to answer those questions. And we'll also show the demos during the session when we just, move from one stage to the another. Now, when we talk about load balancing in Azure, so Microsoft has got two different types of load balancing solutions. One is global and another one is regional. So regional means the load balancer is deployed in a specific Microsoft Azure region, and it can only be accessed or be used by that region only. Means people can come and connect it from anywhere in the world, but that load balancer is only serving the request from that region. Whereas in the case of global, a global load balancer can allow users to come from any closest location, and it will basically route the traffic to the nearest region. So this is kind of global. Now, in terms of different load balancing solutions, we have got the Azure Load Balancer, which is the layer 4 load balancer. And again, it's the regional one. And the second one is the application gateway, which is the layer 7 load balancer, which also supports the web application firewall. The difference between application gateway and load balancer is that application gateway only support HTTP and HTTPS. So that means it is optimized and meant for the web-based traffic. Now, when it comes to the global load balancer, we've got the traffic manager, which is the DNS-based load balancer, and it supports any protocol, be it TCP, UDP, or the HTTP. And the another one is the Azure FrontDoor, which is basically the global load balancer, and it provides the path-based load balancing, as well as this also support HTTP and HTTPS. Now, you could see there are different load balancer, and if required, these load balancer can also work in conjunction. For example, you can use FrontDoor, which is actually used at the edge, and if required, the FrontDoor can have application gateway or Azure load balancer in the backend as well. So depending upon the requirement, they can also work in conjunction. There are some scenarios where it helps to use them together. So for example, if you use FrontDoor with application gateway, it provides the benefit of using the connection draining. So if you want to drain any connections, it is not a feature by default available in Azure front door, but application can add in that functionality if it is used in conjunction. Now, Microsoft has made it much easier in Azure portal as well. So if I quickly hop onto the Azure portal and show you how the load balancing solution looks like, you can simply go and look for load balancing, and it's gonna help you choose which load balancing solutions you want to go for. So simply, if you just want to look at like, does your application use HTTP or HTTPS? If I say no, then I have got only two options, which is the normal load balancer or the traffic manager. So this basically kind of helps to choose and navigate through the different options to choose from what load balancing solution is fit for what purpose. So if I say yes, my application support HTTP and HTTPS, then it gives me two choices, and then I can pick and choose any of the load balancer I want to use. Now, if I'm looking for the service comparison, this page kind of gives me the different capabilities which are available in different load balancer. So this kind of helps to decide which load balancer is required, and which load balancer provides what kind of functionality. Now let's talk about Azure front door. So obviously, we are going to talk about Azure front door as the main load balancers in today's session. But Azure front door is the global load balancing solution. It provides the HTTP load balancing with the fast failover. So it's a layer 7 application delivery network. And what it does is it uses the Anycast architecture, and it also uses the split TCP session. And what that means is that if a user is near to any edge location, so Microsoft has got close to 200 edges, which are or the point of presence location all over the world. And if a user has to communicate to any website which is running on a front door, that user basically connects to the nearest POP location or edge location. And from that location, the traffic basically routes using the Microsoft backbone. Now, the benefit of this approach is if that location is down and if our website is on another location as well, so it can do the fast failover because we only have the connection which is established at our edge. And if the backend is down, it can just transparently move to the another backend. It also provides the application acceleration at Microsoft Edge, and it also provides the global web application firewall at Edge. So Azure Front Door is a hardware solution which is deployed at the Microsoft Edge locations, and it provides the global web capability, means all the OS related vulnerabilities can be detected and mitigated, or can be stopped at the edge location instead of those coming to your website and then your website is processing those requests. Azure FrontDoor also support the path-based load balancing for microservices. So the way the path-based load balancing works, so if you want to define a path for your website, that default path should land to this region. And let's say if there is another path, for example, contoso.com/videos, that should go to different backends. That can be done through the front door load balancing. FrontDoor also supports massive SSL offloading. So just to give you the perspective and scale, FrontDoor as a service, which is basically underpinning services like Office 365, LinkedIn, Bing, Xbox, and things like that. So it supports a massive scale. Means if your website requires massive SSL offloading, so FrontDoor is meant for it because it has been doing it for years for most of the Microsoft cloud services. FrontDoor also supports integrated and static and dynamic content caching. So with the new SKUs which are in preview, the CDN is also combined along with FrontDoor, and it provides static and dynamic content caching. And there is a global app dashboard and service insight. So there is a single pane of glass which allows you to configure your FrontDoor. And on top of it, it also provides you the insight in terms of how the traffic is getting in, what kind of routing mechanisms are put in place, and what kind of attacks are happening. So all those things can be seen in a single dashboard. Now, some of the Azure FrontDoor scenario, as I talked about, it supports the global Anycast architecture. So in the case of global Anycast, what happens is if there is a website, let's say contoso.com, that contoso.com website is kind of advertised to all the Microsoft POP location. So if there are like 200 POP locations, so the website is available to each and every POP location. Now, if a user is coming from any part of the world, that user would connect to the nearest POP, and that basically will connect to the backend where the website is nearest to that POP location. So if the website has got multiple backend, the POP will map that website back to the nearest backend. POP and per app server latency profile. So there can be profile which can be configured based on the latency, which means do we want to provide the nearest website or backend location when a user is coming from a specific POP. Frontend also supports the best-in-class protocol, like it supports HTTP, HTTP2, as well as SSL protocol. FrontDoor is also, or I would say like Microsoft keeps on optimizing the front door. They keep on constantly monitoring and optimize the best, path for the experience. So what is dynamic app acceleration? So as I talked about, so the FrontDoor is a service which is deployed at the edge. So the service doesn't sit in your network. The service sits at the edge. Now, with this service, what happens is you can have any type of backends. The backends could be services like Azure App Services, Azure Storage, service running in a virtual machine. And you can also use services running in on-premises as well. Now, the way FrontDoor works, it uses the Anycast architecture, which means a user has a connection to its nearest POP, and from that POP, that connection is basically established to the backend at the FrontDoor edge where it is kind of deployed. So if you look at the FrontDoor architecture, because this would just give more sense in terms of how does it work. So in this example, we can see that we've got multiple, POP locations which are available, and they're like all across the globe. They're like close to 188 or 190, close to that one. And a user who is making the connection, the user basically connects the, he makes the Anycast request. So by default, if there is a website like contoso.com, that contoso.com is advertised to all these POPs. So when a user is trying to browse a website, he gets a request like from the nearest POP that here is a website, this is the entry point, and user basically connects to that POP, and user makes a connection. So there is a split TCP comes in, and user connection is established between his machine as well as to the nearest POP. And from that POP, there is a connection which is made between the POP to the actual backend. Now, benefit of this architecture is that user is not connecting to the backend, means it's not adding the latency of TCP, handshake. So the handshake is happening at the POP, and POP is connecting to the backend. Now, what happens if the backend is somehow unavailable. So transparently, the connection will be moved to the next backend. So if there are like multiple backend, the connections can be moved to the next available backend, but the user is still connected to the POP. So that's the benefit of the front door. Now, what happens if that POP is down? Or maybe let's say Microsoft is doing some maintenance and then that POP is not accessible. Now, in this case, so since this website is kind of advertised to all the POPs, once the first POP is unavailable, the user would connect to the second nearest POP and would just connect to the backend where the application is running. So this is kind of an architecture which is used for front door, which basically provides a built-in, failover capability for the connections. Now, when it comes to the routing, so front door routes the traffic based on different, methods. Now, so in this example, what happens is, let's take an example if there are multiple backends. So let's say we've got like A, B, C, D, and E, F. These are the backend. And these backends could be in the same region, or they can be, across multiple regions. And they could be like a variety of the backend as well. Now, in this example, so let's say, A, B, D, and E, they are available. So the backend C is not responding. And let's say backend E is kind of disabled. Now, in this kind of scenario, the backend A, B, D, and E, F will only come in the picture. So other backend would not be advertised or would not be used because front door will only use these 4 backend. Now, after this, the next one comes as a priority. So if required, you can even define your backend with a priority. So in this example, the backend A, B, and D, they have got the priority as 1, whereas the backend F, it has got the priority as 2. So treat, backend F as a standby location, whereas A, B, D are the primary location. So the priority would kick in terms of how a user, or how the traffic will be routing. Then the third thing comes in the latency. So the latency is how far a user, or sorry, how far is the connection from the POP location. So take an example, if a website is kind of deployed in multiple Azure region, let's say one region is Australia and second region is like US. And if your user is coming from Southeast Asia, maybe Philippines or Singapore, they will connect to the nearest POP. And from that POP, it will look at what is the latency for the backend. And that latency will determine whether the user should be connecting to the Australia-based backend or should be connecting to the US-based backend. So, and this is kind of a configurable. So, all these things can be configured in the portal as well. So if the latency is defined as 0, that means the nearest backend should be used when it comes to connecting from POP to the backend. So remember this, like user would always connect to the POP, and then from POP there would be another connection to the backend because it uses the concept of split TCP. And the fourth one comes in the weight. So the weight kind of determines like which backend would get what connection. Now, in this example, let's say A and B are close to the 30 millisecond latency because it was configured as part of the configuration that the backend of 30 milliseconds should be chosen. Now, A and B are kind of only 2 which are left, and A can take, so the ratio between A and B is configured 5 to the ratio of 8. So A will always get like, 5 connections where B will get 8 connection. That means B will get more connection in comparison to A. So that's how the Azure front door routing works. So with this, let me just quickly jump onto the demo and show you how do you configure Azure front door and how do you configure your backend routings. So I have got, front door deployed. So obviously I'm using only one front door. I kind of deployed another one just for the testing, and I can simply come and look at the, front door, and it's gonna tell me what kind of SKU I'm using, and I can configure my, front door. So if I look at it, what happens is FrontDoor is a load balancer. So it's not the one like a app services or a VM. So what it is doing is it's kind of load balancing the connection. Now in the backend, I have got a couple of Azure, web apps which are running, and they are the one which are running the website. So if I give you the perspective, so I have got the backend, like, this is my backend where my services are running. I've got another backend, which I kind of stopped. I was testing it, which is running in Australia East, and another backend is running in East US. So I've kind of deployed these backends to two different regions and kind of named them here for the demo as well. And I also have got a URL. So this is my front door URL. So what happens is when a user, okay, my mistake, I closed it. Okay, sorry. Yeah, so by default, what happens is, user can connect to the front door URL, and based on what the backends are configured, the traffic will be routed. And as I said, these backends could be in a one region, and these backends could be in multiple regions. So as a user, I will go and always look at this URL, and I will, connect to my website. So I can have different load balancing mechanism, routing mechanism that will determine where my website needs to be. So you could see that my load balancing is just moving this website from Australia East to East US. Now, I can go and connect to my website directly as well, because these are the web apps and I can connect them directly. So that option is still there. But obviously, since we are using front door, instead of coming users directly to the website in that region, they basically go and connect to their nearest POP. And from that POP, they basically connect to the backend pool of resources. Right. So that is basically how we look at the front door configuration. So before that, I just wanted to show. So when it comes to front door, you would find there are different options. One is the front door, which has been there for a long time, and there is something called front door standard and premium service, which is in preview. So this is completely new service, and you see a new resource provider for it, and you will find different options altogether. So currently it's in preview, and you would find once it becomes GA, you might find it a little bit different. But just to give you the perspective, if you try to look for this front door, I may not be able to find these services because they are like, I'm using the premium one, and it's part of the new SKU, which is in preview. So once the front door is created, the next step is configuring the endpoints. So I can come on to the endpoints, and I can configure the endpoint. So in my scenario, I've already configured the endpoint, but I would just quickly walk through and show you how the endpoints look like. If required, you can use the domain name. So I'm currently using the Microsoft default domain name, which is the Azure FD.net, and whatever is the prefix I've given, based on that, my front door is created. But if I want to use my own domain name, for example, contoso.com or tactalk.cloud, I can do that, and I can onboard that domain. I just need to verify it. So I'm going to edit this endpoint. So I'm going to use the default, front door domain name. The second option is the origin group. So origin group is pretty much like what my backend is. Is it a single public IP? Is it a domain name? Is it like a app services and things like that? So I click on the origin group, and I can manage this origin group from here as well if required, but I can simply go, one by one and, configure within the single, endpoint manager as well. So, so origin group is I'm just grouping my websites together, and I can, when I use the path-based routing, I may create another origin group and I'll add it and I'll give it a different, locations, maybe, slash video or things like that. So I can keep adding more, origins to use the path-based routing. Now, in this example, what I'm doing is I have got two different websites which I've added. Now, if I need to add a new origin, because as I said, the front door supports different type of origins. And if I look at the drop down, it can support like storage account, cloud services, app services, API management. And if required, you can even use the application gateway, public IP addresses, and custom. So FrontDoor supports backend, which can be running in Azure or on premises, or it could be in any different cloud as well. So if it is running in Azure, it will do the auto discovery and it will find out what's the header name and some of the information. But if it is somewhere else, like an on-prem, it can support it, but you may need to provide additional details. So if I edit the existing endpoint, so this is how it looks like. So it has got the same host name and host header because it's a Azure web app. It's using port 80 and 443. It has got the priority as 1. If I just make it as a priority as 2, means this particular backend will have a second priority. Means this backend would only be used if the backend which has got the first priority is not used. Now I've got the wait algorithm as well, which is kind of configured. So this needs to be configured for each and every endpoint. So if I just look at, so this is how I have configured my backends. And now within that backends, I can define different protocols, like am I going to use the HTTP or HTTPS, and how I'm going to do the load balancing. So my probe methods are we going to use the header or the full GET request? Means the difference between head and GET is, now if my backend, if I use head, which is kind of recommended, basically it's a header, it's just going to look at the header and quickly going to confirm the backend is working fine. Whereas in the GET, it's going to get the full body in the request for the confirmation. Then I can define in how many seconds that interval has to be there for the probe, as well as different load balancing mechanism, like how many samples it should send and how many samples should be successful. Means out of 4, 3 health probe should be successful in order to call that backend is running fine. And here I define my latency sensitivity in millisecond. So if I change it to 0, what would happen? This would always prefer the backend, which is closest to the POP location. So this can be changed to 0 if you want to serve the content, nearest to the POP location. So if a user is coming from a POP location, ideally that POP should be close to 25 to 30 milliseconds range, and then from that POP to any closest Microsoft region or location where the backend is. So if I say 0, that would just prioritize the nearest one. And once it is done, I can simply come and update it. Yep, it's done. Now, the second option is the route, and route will determine like how traffic needs to be routed. And that basically, allows to enable this backend or not. And we can also define whether we are using the path-based pattern to match. Do we want to redirect every HTTP traffic to HTTPS? So those kind of routing rules, can be configured. Whether we want to use the caching or not, do we want to ignore the query string or use a query string? So all those kind of routing related decisions needs to be configured in order to make this to work. So that is all done, and obviously I've got my website which is running, and if I just go and refresh, I can see that website is returning the traffic back to Australia East, because now what I've done is I've changed the latency to 0, means this would not be going and going to US, because in the past I was using the 50 millisecond, means it just could go to US or Australia, because both backend were within the 50 millisecond range. Whereas now I've selected 0, that means it should always go to Australia East, because that's the most nearest one. So that's how we kind of configure the routing. All right. So FrontDoor also support the security. So there are different security capabilities which can be used along with FrontDoor. The first thing is FrontDoor uses the web application firewall. So as we talked about, it supports the web at the edge, means if any traffic which is kind of a malicious, and if it has got any OWASP related vulnerabilities, that can be detected and protected at the edge location. So Azure FrontDoor, it is only HTTP and HTTPS based service, means any type of attack which are like TCP sync attack or something which is not HTTP and HTTPS, those traffic will always be dropped, by default. Now, on top of it, Azure FrontDoor also has got the DDoS protection. So there is a built-in DDoS protection, and any traffic which is a malicious traffic, that is also kind of dropped at the edge level. If required, the Sentinel and WAF can be connected together as well. Now, this is just an example of how the WAF and WAF profile looks like, and I'll quickly show you a demo for the WAF profile as well, and how does it look like. So as your web application firewall, it also supports against a malicious bot. So that's kind of a new options. You can configure the custom rule and enable against the bot protection. And that information is basically comes from the Microsoft Threat Intelligence. So the Threat Intelligence provides information about the malicious IPs where the bots are running and the IPs of the system which are compromised. So the traffic can be blocked from those IPs. Now, along with it, there is a new option which is introduced in FrontDoor. That's about the origin protection. So as we talked about, the FrontDoor as a service which runs at the edge. Now, obviously, there needs to be a backend, and that backend needs to be a public IP-based backend. So now, in a case, I want to protect my backend, and I don't want people to connect to the backend. So in simple example, here we can see the user is trying to come from, user is trying to come from, a website, and he's basically trying to connect to the front door, and obviously he's connecting to the backend. Whereas this user, if he knows the backend, IP address, they can directly connect to it. Now, if you use the private endpoint, which is the feature of Microsoft Azure, a lot of Microsoft Azure services support the private endpoint. What it will do, it will basically, protect the backend, means user cannot connect to the backend directly, and backend will only accept the request coming from the front door. So this is kind of a, service which is, I believe, is only available in Azure front door, where the origin can be protected as well. And obviously, the backend service should also support the Azure private endpoint. So with this, I'll jump back to the demo, and I'll show you how the how the web application firewall and rules work, and how do we protect it against the OWASP vulnerabilities. Now, so the example which I was giving, so here is my website. This is accessible by FrontDoor, and I also have got the website which I can open up directly, because these are the endpoints, or I would say the backends, which are publicly available as well. So if I want to protect them, I would need to use the private endpoint. Now, in terms of the um, WAF, WAF capability, so if I just jump onto the, yep. So here is the WAF. So I have configured the WAF policy. So in order to configure WAF, so what happens is if we come into our front door configurations, so there is an option of security. I can click on security and I can assign the WAF policies. So the policy is kind of, assigned, and this is my WAF policy, and I can simply go and, connect from this blade as well. So the policy has got the policy settings, and it can have its own managed rule. And so Azure Web Application Firewall, it protects it protects against the OWASP vulnerability as well as the bot attack. Now, if I've got something like a SQL injection attack, it can basically, block that traffic. And I'll show you in a demo how does it look like if I'm coming through the front door versus if I'm coming directly to the website. So anything related to the OWASP, they are basically stopped at the edge level, but anything related to the bot attacks as well, those are also applied. So Microsoft has got the bot manager rule set, and that has got a specific set of scenarios. They're like good bots and bad bots, like how the how the behavior should be if the traffic is coming from these kind of bots. And if required, there could be custom rules which can be created, like what we want to do in case if, let's say, a traffic is coming from maybe a geolocations, maybe from an IP address, or maybe a specific size as well. I can even create those kind of rule and take an actions according to the requirement. So take an example, maybe I'll choose geolocation. Then it shows me which country, I want to, select, and then I can select what my action gonna be. Am I gonna deny the traffic, going to log the traffic, or redirect the traffic? Those kind of actions can be taken by creating the custom rule as well. So that's the capability which can be used by using the web application firewall. So let me quickly show you. So I've got a cheat sheet where I've got the SQL injection attack. So in this example, since we are using WAF, now what happens is this is my front door URL. And if I try to do the SQL injection attack, so since I'm using WAF, my traffic is blocked. So the front door has blocked the traffic because it is using the WAF capability. Whereas my other endpoints or the backend, they're not using the WAF. Now, in that case, what would happen if I use this SQL injection? Yeah, it's fine because it's working. So I can have a malicious code, deployed in my SQL, and I can compromise the security of my website. That's something I can protect it by using the WAF or by configuring my website to protect against the common OWASP vulnerabilities as well. But if if the WAF is there, the traffic is immediately denied at the edge level. So that's how the WAF comes in, and that's how the WAF basically blocks any malicious traffic. And obviously, on top of it, if I configure any custom rule, they will also kick in. So for example, if I say any traffic coming from this IP address range, which I've detected, and want to stop it, I can do it as well, and that traffic will be blocked before it enters to your backend. Now, what happens when you need to migrate a website or anything from on-premises to Azure? So this is something which I've done in a couple of projects in the past. Obviously, this is kind of a very small kind of overview, but it includes a lot of steps when it comes to migrating a website. So simple example, you need to configure Azure DNS, and you can copy the DNS record in Azure DNS. So I'll take an example. There was a customer who was looking from moving away from on-prem to Azure, and they wanted to move away or migrate their DNS to Azure DNS as well. So the way we achieved is we copied all the DNS records in Azure. So there were like some 200 DNS records which were configured. So there was no point of hand typing and configuring it because there were like different kind of text records which were like quite long and cannot be handwritten. So the way we did was like we exported the zone file and we imported the zone file in Azure DNS. So we kind of made sure that both DNS on-prem and Azure have got the same record, because when the failover happens, and let's say, if a user, because of the DNS cache, is going to the previous IP addresses, they would not, get any sort of error message. They would still be able to, connect to the website. And then we moved the website from the VM to Azure App Services, verified all the testing, and then we did the DNS cutover, and we moved the name server from on-premises, DNS or on-premises location where they were pointing to the Azure DNS, which means the Azure DNS became the main authorized and authoritative server for the name server requests. So that's how a website can be moved from on-premises to Azure. And obviously, we also configured FrontDoor. The whole region or whole reason to migrate that website was because in on-premises, that website was, getting, being targeted by different kind of attacks. And by moving it to the Azure Web Services as well as FrontDoor, we kind of protected it against those malicious, activities which were happening against that website. All right. So with this, I'm kind of done, and I will hand this over to Nirmal to talk about analytics and dashboard.
Thank you,
Nirmal, over to you.
Yep. Thank you. What I'm going to cover next is to go through some of the new improvements we've done on the FrontDoor standard and the premium SKU, focusing around analytics, which is a core piece for a lot of customers when they set up Azure FrontDoor, when they set up CDN, for them to really understand how many users are consuming the service, and also really be able to break down where these requests are coming from. So part of the premium capability we are looking to add, which is in preview today, we've added a built-in dashboard, part of our analytics and metrics dashboard. So I'll do a quick demo and show what this really looks like, and also do a bit of a comparison as to what we had in the current release of FrontDoor and how we are looking to improve with the new SKU that we are looking to introduce. So with that, let me share my screen and go to my Azure FrontDoor instance. So here, what you're looking at is this is an existing Azure FrontDoor deployment. This is deployed using the current Azure FrontDoor product SKU, which is generally available. So if I go in here, what you would notice is we have an overview page, and here you have some of the basic data. So here you can see how many requests we are getting, the size of the request, response, things like that. So this is what we call as the platform metrics. And then you can always go to diagnostics and send FrontDoor diagnostics to either log analytics, or you could send them to a storage account as well if you want to keep them for a longer duration. So the improvement from this current implementation is to add a couple of dashboards built into the platform itself. So I'm now going to switch back to the FrontDoor Premium SKU. So here I've deployed Azure FrontDoor, but when I deploy, I've specifically selected the Premium capability. So the way how you differentiate is the type of the resource is different, and also it's saying preview over here because this is the preview capability at this stage. So when I go into this resource, you will see that the component layout is somewhat different from what we had in the previous release. So here we have a dashboard. We kind of group down what kind of components are configured. So it's going to show the FrontDoor URL. And as Deepak walked us through, it's going to show the origin that you've configured. It's also going to give you the other things that you've configured. So here we have a WEF policy that we've turned on. We also have different routing rules configured. So that's really at the dashboard. We are showing customers what's been configured in the current FrontDoor instance. But what I really like is what we've done around the analytics. So when I look at the analytics section, you can see here we have two areas. So there's analytics reporting, and then we have analytics for security. So one thing unique about this is it's out of the box. So once you configure Azure FrontDoor, this will be part of the configuration. You don't have to go in and set it up with log analytics or set it up with another component. So it's really out of the box. You don't have to import any kind of workbooks. This is built into Azure FrontDoor. So here we have a couple of things. I'm just going to narrow this down to last 24 hours. So this is now going to show me, based on the domain I've configured, how many requests I get. Also break it down into the different response that it's getting from the web. Also, what I can do is I can go to the usage tab. It's also going to give me rich information to get an understanding of how many requests I've had, also traffic from the client to the edge, and also the response we've had from this website. So things like latency, all of that data is available over here in this dashboard. Also, if I move on to traffic by location, we can also see the distribution where the users are coming from. So this is super important to really understand where your users are. So what we've done is to simulate, we've set up a couple of health probes in different regions using application insights. So here it's probing the website, and I can see all these different telemetry coming in based on the origin of the user IP. I'm breaking down, and it's showing me how many requests I've received, and also the response rate for each request. Obviously, we have most of the requests from here in Australia. Deepak and myself, we've been trying this out, making sure that the application is performing as expected. We can also see things like caching data. So if you are doing any kind of static or dynamic caching, that information will be also available over here. The other things are around top usage and top referrer, top URL. Those information would also populate depending on how you've deployed the application, and also depending on the users that that are connecting. You can also download this as a CSV. But if you really want to preserve this data, because we keep platform events up to 90 days. So if you want to keep it for, let's say, 5 years, or you want to keep it for 100 years, what you can do is you then go to diagnostic settings. So very similar to what you've done before, you would be going into diagnostic settings, and you would be sending this information to log analytics, or you can send it to a storage account, and you can preserve that data. Without doing any of that, you would still be able to access in the reporting tab out of the box. You will be able to go see how your application is performing using this tab here. The other one we've done is, obviously, with the focus around security, we've added a dashboard for security as well. So Deepak talked about the different WAF configuration we can do. So based on that, any incidents we detect, and if we do block any requests, you would also be able to see all of that data here in this dashboard as well. So again, it's out of the box. You don't have to go configure anything. We would populate this data and give you that visibility as to how you are performing in terms of the WAF capabilities and the rules that you've set. Same as before, you can either download this or you could go to the diagnostics settings and you can go in and configure this. You can send it to Log Analytics, which will then integrate with things like Azure Sentinel, or you could store this into a storage account as well. So that's what we've done in the analytics space. So what I will do is I'll just go back to my slides and go through the different certifications that we have for Azure FrontDoor. So Azure FrontDoor, as Deepak mentioned at the start, it's widely used within Microsoft. So a lot of the services that you consume today is actually fronted by Azure FrontDoor. So a lot of our public services, things like Xbox, Office 365, these all use Azure FrontDoor. So it's essentially a battle-tested service being used at Microsoft for a number of years. But we also want to offer this as a service for customers to go consume and have the best of breed for their applications to be protected, as well as improve that user experience when you have distributed users who are consuming your services that are hosted in the public cloud. So FrontDoor also has a number of certifications. So starting with ISO, multiple certifications from ISO. Also, we have specific security certifications as well, such as PCI DSS, a number of certifications in US, specifically the DoD certification. So it's essentially a service that's been battle tested and also gone through a rigorous compliance reviews to achieve all these different certifications and also maintain them in an ongoing basis. So with that, I'll do a quick recap. Based on what Deepak did, I think a really good introduction to what the solution is, and also a good walkthrough around how we can configure it, what are the different aspects for us to configure. We've also looked at the analytics side of things. Once this is all up and running, how do you now see the telemetry? How do you now see the data based on the usage of the application? So what I do want to cover here is really to look at what are the different use cases. When do you want to use Azure FrontDoor? When is it making sense for you to use it? So one of the key use cases is really for any application that's public facing. So if you have an application that's consumed by the public internet, Azure FrontDoor is an ideal candidate because it will allow the application acceleration. So allows the user to leverage our wide edge network, get connected to the closest Microsoft Edge, and then essentially ride through the Microsoft backbone and get connected to the backend services. So anything public-facing applications, it's a good candidate. Also for content acceleration. So when I say acceleration, in the current FrontDoor SKU, we have a focus on dynamic content. But with the standard and the premium SKU, we are also bringing in the CDN capability together, which means that if you have static content, you can also use Azure FrontDoor. If you have dynamic content, application libraries, all of that would work with Azure FrontDoor as well. So any kind of content delivery, you could also leverage Azure FrontDoor for these purposes. The third area is if you have a microservice-based architecture, if you have your application deployed with different components, you can have part of your application fronted with Azure FrontDoor as well. This is super important if you are looking for some kind of a migration scenario. You want to move your application from either on-premises to the cloud, or you are looking to do a platform change on the cloud itself. You could have certain components of the application fronted by Azure FrontDoor, and that will also help you to do the seamless cutover from one to the other. I think Deepak did cover his experience in doing some of these migrations. It's a seamless process where you manage the DNS entries, send all the requests to Azure FrontDoor, and then use Azure FrontDoor to then decide, what is my backend where I should send the traffic to. The fourth and the fifth scenario is again focusing specifically around content delivery and to be able to have static content cached and have them available at the local edge for users to go and consume. So these are the ideal use cases for Azure FrontDoor. But in summary, do really want to highlight the fact that Azure FrontDoor is operating at the edge would mean that the traffic would get inspected, and we would apply web application firewalling, we would apply bot protection, all of that at the edge itself before the data packet essentially enters the customer's VNet on Azure. So it adds that extra layer of protection at the edge and drop any kind of malicious traffic before anything is really entering to your own VNet. We've also covered things around security. So security was one aspect that Deepak did cover. We've also covered how FrontDoor will enrich the user connection and provide that acceleration. We've also looked at, with the Microsoft wide area network or the global network, how we can give fast access to the content. It's also developer friendly. So all of the the demonstrations we've done, you could use the Azure API. So Bicep, ARM, there's really good support for things like Terraform. So you could really use any type of provisioning method. And essentially, for the developer, they could use the same platform to go build the application, deploy the application. And also, they can use the same platform to go in and have a CDN in front of it by using Azure FrontDoor. So these are some of the capabilities that's available in the new SKU. So it's still in preview. So watch out for some of our announcements at Ignite. We would be showing some of the capabilities that we are working on. And with that, I'm going to wrap up the session and look at opening up for any questions that we have. Thank you all for joining.
Great, thanks Deepak, thanks Nirmal. So we do have one question that came through from our Learn TV platform, which is, Deepak, can you elaborate a little bit on dynamic caching, so how it works and how the rule can be configured?
Yep, Deepak, if you want, I'm happy to take this one. So with the dynamic caching, you can set specific file types that you want to go cache. So we have those settings available within the FrontDoor configuration. So if you have a specific, let's say there's a Java library that you want to cache in the platform, you can have that specific file type added. And based on that, we would go in and cache. We also have a rules engine part of Azure FrontDoor. So if you want certain things specifically cached and kept for a certain duration, you could also configure that part of the rules engine as well. We can, I think, share a couple of other links around the caching configuration. So let me add that into the chat.
Great, thanks Nirmal. Yeah, if you just send those links in the chat, I can also add them to the check-in link for everyone as well, so they can get those within the next 24 hours. I think that is pretty much bang on time. We'll give everyone just one more minute to see if there's any last-minute questions that came through. But just a reminder that the links in Nirmal and Deepak's presentation and demo are in that check-in link with the event code 14669. And we've got the survey there as well with the same event code. And just a reminder that anything missed from today will be on our YouTube channel after this in a session straight away. So there will be the on-demand version available. I think that is it. We're on time. So thank you so much again to Nirmal and Deepak. And thank you to everybody for tuning in. Have a good rest of your afternoon, evening, or morning. And we'll see you next time for another Microsoft Reactor live stream event. Thanks all. Thanks both.
No worries. Thank you all. Thank you so much.
Cool. Thank you.